Hello, I'm Mr. X, Mentor of Mathematics, and this lesson is Trig 098, a review of our Cartesian or rectangular coordinate system, quadrants and axes, a prerequisite to taking anything called Trig 101. You should be a whiz at plotting points in Cartesian coordinates. You should know all about our quadrants and our axes. By custom, we say this is the x-axis and positive infinity is this way. Likewise, we might call this the negative x-axis, and negative infinity is a bazillion miles that way. And I know bazillion is not in the mainstream of either mathematical or engineering terminology, but negative infinity is infinitely far in that direction. Positive infinity is infinitely far in this direction. There's an infinity up here for y values, and infinitely far in that direction is negative infinity for the y. So we can call this the negative y-axis, and we might call this the positive y-axis. But it's all the same axis. It's all the y-axis. And so where's our origin? Right here in the middle, the point 0, 0. It's where it all starts. Quite often I will just put a y here and an x here. I might even leave off these arrowheads over on this side. I tend to put my arrowhead on the positive y-axis and the positive x-axis. And you have to be totally comfortable about plotting points and so forth. That has to be automatic for you, or you're really not ready for trigonometry. Now here's a line from basic algebra. We're going to say it goes to the point negative 2, 0. That's the ordered pair at that point right there. And it goes to this point, 0, 3. Can you get the equation of that line? Well, do you know the slope? You know the y-intercept. I hope this is review for you. The equation of this line could be expressed in a form we call slope-intercept, y equals mx plus b, where this m is the slope and this b is the y-intercept. Well, we get the slope very easily from the legs of this triangle, as it turns out. If we look at the triangle inside of here, where this is 3 units and that's 2, we get the slope immediately. Rise over run is 3 over 2. So our slope is going to be 3 halves, and as a decimal, that's 1.5 or 1.5. The y-intercept is this value here, where the line crosses the y-axis. So we can just write this, 1.5x plus 3. We could write it as a fraction. That slope is 3 over 2. It's a positive slope. And that's the equation of the line. This stuff should be automatic to you before you start studying trig. If you're baffled by anything we've done here, you probably need to review. Is it abundantly clear that this right triangle has legs of 2 and 3, and so the slope of our line would be rise of 3 over run 2? This is our slope, and 3 over 2 expressed as a decimal is 1 1/2 as 1.5. Now I'm going to change the slope of this line, and you're going to be able to write the equation of that line. We have a line that goes to the point 0, 1 and the point 2, 0. 2, 0, 0, 1. What's the equation of that line? Can you figure out the slope from the rise over run? This is 1, this is 2. You need to be able to write the equation of that line in slope-intercept form. You should do that now. Between any 2 points on the line, we have this shaped triangle drawn with a vertical and horizontal component. This little sketch you should be able to envision between any 2 points on the line. Between this point and this point, we get that same triangle. Pardon my artwork, but between any 2 points on the line, we get that same shaped triangle. They're all similar. In fact, between this point this point, we get the same shape of a triangle with a ratio of 1 to 2. Between any 2 points, you get this little triangle with a ratio of 1 to 2. This little right triangle. So, did you get the equation of the line? Well, the equation of the line in this form we call slope-intercept, because the M represents slope and the B represents the y-intercept. Here's our y-intercept B. That's the value of B. Actually, this is the value of B right there. And what's the slope? It's negative 1/2. Negative 1/2. So, the equation of the line. With decimal or fraction, either way. And before we leave this graphic, you need to understand that between any 2 points on this line are an infinite number of points. Between this point on the line and this point on the line are an infinite number of points. Right in between there. So we're going to take a little closer look at this line before we launch you into trig. This is the same line we just had, negative slope, slope of negative 1/2, goes to the point 0, 1 and 2, 0. So my question to you is, when x is negative 5.4, what's the value of that y? What's the value of that y? And what are we talking about here? Well, we're talking about the y-coordinate on this line when x is negative 5.4. Well, when x is negative 5.4, it's on this dashed line. These numbers are a little fuzzy, admittedly, but here's negative 2, here's negative 4, here's negative 6. So this dashed line represents x equals negative 5.4. Negative 5.4 for an x value would have to lie on this dashed line. So what we want is the y value. I want the coordinates at this point. The point on the line when x is negative 5.4. Here's the equation of the line. Indeed, I want this value of y because that's the value of y at this point that lies on the line when x is negative 5.4. Well, you could just put a negative 5.4 in for this x and do it that way. Hopefully you can do this with mental arithmetic. I'll go ahead and write it out. It's really not that complicated. If you can do this mentally before seeing it written down, you're definitely on your way to being successful in trigonometry. If you don't see it, even after it's written down, you probably have more work to do. So it turns out that this point is going to be on our line. When x is negative 5.4, y is equal to 3.7. And if your teacher doesn't like decimals as much as fractions, these are equivalent. Negative 5 and 2/5 is the same as negative 5.4 or negative 5 and 4/10. 3 and 7/10 written as a decimal, 3 and 7/10 written as a mixed fraction. Now a quick word about the axes and the quadrants. We quite often label the quadrants with Roman numerals. 1, 2, 3, and 4. You don't have to use Roman numerals, but it's kind of a convention. This is the first quadrant. And in the first quadrant, both x and y are positive. In the second quadrant, x is negative, but y is positive. In the third quadrant, both x and y are negative. And in the fourth quadrant, x is positive, but y is negative. Now, do you know the equations of the axes? Go ahead and write the equations of the x-axis and the y-axis. What are their equations? What's the equation of the x-axis? Y equals 0. Everywhere on the x-axis, the value of y is 0. This is the point negative 10, 0, negative 2, 0, 0, 0 is the origin, 4, 0, 6, 0, 8, 0, 10, 0. Y is 0 everywhere on the x-axis. So the equation of the x-axis is y equals 0. Indeed. But do more than just write it. Understand that every point on the y-axis has an x-coordinate of 0. So these points would be on the y-axis. Are all these points on the y-axis? Do we know that they're on the y-axis? Of course we do. And how do we know? Well, because the x-coordinate is 0. In Cartesian coordinates or rectangular coordinates, when the x-coordinate is 0, it's on the y-axis. And when the y-coordinate is 0, it's on the x-axis. Having fun yet? You're almost ready for trig.